Hey everyone, how's it going? This is Idan Aronson from Flycode, and today I have a very special guest, our first guest in the podcast that we're starting to do. His name is Gil Tayar, and he is, I think, the most experienced developer I know personally. Gil has been a software engineer for 35 years. An architect, a teacher, a mentor in hackathons, one of which I organized in the past. That's how we met. And really glad to have you here. How's it going, Gil?
Hi, Dan. We go way back, it seems.
Yeah. I mean, what year was it? Like,
that was the Wix days. So 2015, something like that.
Right.
Yeah.
Wow.
Can I say how old you were?
Yeah, sure.
Go ahead. You were like how much? 17, something like that.
No, I was 16.
Oh my God! Yeah, you were a bunch of crazy talented kids. That did amazing things. I was amazed back then when I went to that.
So I'll give some context for the audience. Basically, we started a hackathon. And we've done it in WeWork before it was bad in Tel Aviv for teenagers that was interested in web. And Gil graced us with his mentorship for
3 days, 2 days, something like that.
Yeah.
I made a lot of kid friends, and and they were like, "Oh, thank you and everything for your experience." And I said, "Thank you. When I get to the ripe old age of 70 and I need jobs, that it is you I will be coming to."
Now I see your motivation. Okay, so the whole thing was
job security. That's it.
Well, if I can say one thing is, you worked in some very interesting workplaces, right? In Wix and then in Amplitude, and now it's Rainforest.
Yes.
Is there like a general theme to all those places? Like,
yeah, I look back on 35 years, and except for one place, all the positions I had, all the jobs I had, were always greenfield, starting from Git init. Well, back in the days there was no Git, but you get my point. Yeah, except for CloudShare, which I came to a huge mass of code, and it was very well written, so I had no problems. Python, but otherwise it was from start. So Wix, we built what was then Wix Code. Now it's Wix Corvo. It was from the beginning. Applet Tools, we built the whole visual grid, what is called now the ultra fast grid from Git init. And Rainforest, we rebuilt the whole web development group from zero. Yeah, it was.
And yet
that's definitely a core theme.
Yeah. And yet these projects, like these companies, grew like huge, right? It's always like they became like huge companies. Each one of them.
Wix, yeah, Wix started. I started at 1,000. I think today there are like 5,000 people. Appleton is working well. They're growing and everything. I wouldn't say they're huge. And Rainforest, we grew from like 2 developers to 15. So.
Yeah,
so this is good. Yeah,
and it's amazing. I mean, huge in the sense of you have time to actually have also time to look into more bigger questions about software, right? Like it's not just like building the next feature or onboarding the next developer, but also kind of getting a look on what are the language we're using, what is the tools that we use to develop.
Absolutely. It has always interested me. When I go back, like since probably 98, the whole how do we develop and what's the optimal way to develop from a technical standpoint, not from a people standpoint. I believe in people, but the technical part always interested me, was always there in the background and a lot of times in the foreground. That's what I did at Apple Tools. Besides developing the visual grid, I developed the methodology, and at Round Forest, I made it much more coherent and nice.
So, lastly, I saw that you, recently, I saw that you're championing a new proposal for JavaScript.
Not championing. Champions are people from the TC39. We'll talk about that in a second.
Yeah.
Committee that say this proposal is good. I'm all for it. I'm a co-author. I'm a co-author of the proposal.
Of a new a new proposal for changing JavaScript, which is a language. I think you're the most experienced person I know. It's used it for so many years, right?
From 98, yeah, something like that. Yeah.
So, proposal to change this language that you used for so many years, and make. And you know what? Let's just take the lead. Can you tell about this proposal?
Yes. First of all, what is a proposal? I mean, JavaScript. JavaScript is a language that changes. There was a time where it stopped changing, somewhere between 2010 and 2015. I don't remember. Don't catch me on mistakes. And then ES6 was standardized in 2015. It's called ES 2015. And then they decided on an interesting strategy. And we'll talk about who they are. But in a second, every year, a new version of JavaScript will come out. And by the way, the version of JavaScript will always, 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 forever, and it's a promise, be backward compatible to the old versions. And the reason is very simple. Our programming language can theoretically say, well, we broke compatibility here and there. Once you upgrade, just change your code and you're done.
Right.
JavaScript is the language of the web. You can't go to, I don't know how many billions of pages and tell them, yeah, just do this little fix here, because it's basically impossible. And if you break that and you break the web, you're done. And there are many, I won't go there, but there are many places where they inadvertently broke the web and it crashed some sites, and then they had to fix, the spec a little bit to make sure that they're not breaking anything. So every year comes out a version of JavaScript with more features, with enhancements. Things that we take for granted today, promises, async await, ES modules, top-level await, destructuring, etc., all came from this process. From ES 2015 and onward, even before that. But before that, the going was very, very slow. Today, the going is faster. Who's responsible for JavaScript, the language? And the answer is TC39. It's Technical Committee 39. 39 in an organization called ECMA, the European Consortium Manufacturer Association, something like that. Something European, something manufacturer, something association. It's the language that somebody in the past history decided was going to be the place to standardize JavaScript. And that is why we in the spec itself, it's not called JavaScript, it's called ECMAScript, ECMA script. And the reason is that JavaScript is a trademark of Oracle. Oracle bought Sun. Sun was the first developed JavaScript initially. So it's still a trademark and you can move it. So it's called ECMAScript, but everybody calls it JavaScript. So TC39, it's the committee that is supposed to standardize JavaScript. And that's what they did initially. After they standardized it, they started adding features. And the way this works today is every year a version comes out. But in parallel to that, you put a proposal to the committee. The committee is around, 60, 70, 80 people, I'm not sure exactly. And you put a proposal and they meet, I think, once every month, once every 2 months, something like that. And you put the proposal and And the proposal doesn't have to be like exactly what the spec is, but this is my idea. Do you think it's worth considering? And the committee can say, nah, I don't think it's not a good idea for JavaScript. Or they can say, nah, but if you do these changes, come back to us and we'll talk some more. Or they can say, yeah, good idea. And then it moves to what is called stage 1. Now we go through stages, stage 1, stage 2, stage 3, and stage 4 is it's standardized. We're done. I don't want to go, we can go into the stages, but basically stage 2 is we have to finalize the spec, like the bits and the dots. It's a lot of tedious work. Stage 3 is we've done finalizing the spec. We've gone through all the comments. We're done. Please, somebody take and implement this. This is a requirement. So let's say Apple implements it in WebKit, or Google implements it in Chrome, in V8. Somebody, I think they need at least 2 implementations in the field to make sure, one, it doesn't break anything. Very important. That's where they test that things break, and 2, to see that the feature works, like in the real world. Once it passes that, stage 4, boom, done, into the spec. And that's where it gets, so the version comes out every year. They don't know what's going to be in the version. They don't, just whatever is ready at stage 4 will be in that version. So the history is cool and interesting, but we wrote the proposal, which is a very general idea, and we proposed it to TC39, and it got accepted to stage 1. Wow. So what we talked in general, but what is that proposal? How does it change JavaScript? How does it enhance JavaScript? It basically, the idea is to enable developers to add type annotations to their JavaScript code. Yes. So very, very similar to type systems like TypeScript and Flow, where they also allow you to add type annotations. Like, for example, if you have a function foo and it returns a number, you can say function foo and then colon number. Both in TypeScript and in Flow, you add the colon at the end and write colon number, and that is how you say this function should be returning a number. And then TypeScript and Flow, if it returns a string, they can show an error in the IDE or when you run TypeScript. But today, TypeScript and Flow have a problem. You can't run TypeScript code. You cannot run Flow code because JavaScript doesn't understand it. Okay? So what they do, TypeScript and Flow, they transpile it. They transpile it to JavaScript. They compile it to JavaScript, and that is what is run. Our proposal says, look, let's add certain places in JavaScript, for example, in the end of the function colon and something, where we allow you to write whatever you want within limits, okay? And that is the type annotation for the function. And there are like multiple places. In the parameter, you don't say A colon, comma B, you say A colon Boolean, comma B colon number. So you specify the types of so we allow JavaScript to have these, we call them syntax and type annotation syntax space. We allow these spaces where you can write whatever you want within limits, okay? And JavaScript, the ideas will completely ignore them, okay? So you write your code just like you write in TypeScript. JavaScript will completely ignore the types, will treat them as comments, and that's it. That's the proposal. The proposal defines what are those spaces in the language that are allowed. And surprise, surprise, they are exactly like what TypeScript and Flow needs to do their stuff. So in the future, if this proposal gets accepted, you will be able to take TypeScript code with all the type annotations, copy paste it into the console, and have it work.
Which is just like you would work with JavaScript back in the day before TypeScript, when we didn't have to transpile our JavaScript, right?
Exactly. Exactly. And not only, not only in the console, you just write TypeScript code and it works in the browser. You don't need transpilation. In the browser, in Node, in Dino, whatever backend runtime you want. Yeah, and that is the proposal. A lot of people think we're adding TypeScript to JavaScript, and that is not true. We are adding the ability for most of the TypeScript code to run without transpilation. And that is the point. TypeScript and Flow. Yeah.
And I remember seeing you posting about this proposal. And for me, it made perfect sense because I remember a few years ago, we were talking about TypeScript. And I would say bluntly, you were kind of a hater on TypeScript.
Yes.
And you had a really good reason for it, which was the TypeScript requires transpilation, the transformation from one code form to another. And it really blocked people from using JavaScript just everywhere, like putting it, as you said, in the console or just connecting a script into an HTML page and that it will work. You need to add an extra build step. And
yes.
And then when I saw this proposal, I was like, oh, so basically Gil made TypeScript, wants to make TypeScript to comply to this, so it won't break the way people are working with JavaScript.
Absolutely. My dream, my vision, is that I can write a whole JavaScript application with types and with ESM, with ES modules, with Node modules, NPM install and everything, and have it work not only without transpilation, but without bundling also, at least in development, so that I can just write the code and run it like in the good old days,
yeah.
Okay? Without any need for any kind of tooling. That is my goal currently. Let's reach that. So one part of the goal is let's take most of the code today, like at least half, is written in TypeScript. Okay, so let's take what we write today, have it not transpile, and have it. The second goal is how do we do it without bundling? And there are solutions to that. My company, Round Forest, are experimenting with that, and we have a solution where we don't bundle at all and use ESM natively in the browser. But that's totally
another story.
Yeah, that's totally another story. But the first step is let's take the language that most people are using today, which is TypeScript, and make it conform to that vision. Enable, students. Students today, a teacher in the issues in the GitHub repository with the proposal who told me, look, I have students of mine copying paste code from Stack Overflow, and they don't understand why it's not working. It's not working because it's TypeScript code. And he says, and that guy said, I want this proposal to happen because my students will have an easier time with that. A lot of people say, no, TypeScript is complicated for beginners. Well, maybe it's a little bit true, but in practice, most of the code the students out there will see is TypeScript code today and not JavaScript code.
Yeah, I feel like the main barrier today for developers, especially junior developers, and we both are teaching people, used to teach at least for some time. And one of the things is tools and tooling, and get your system ready, get your development environment ready for writing the simplest Hello World program is so complicated.
Exactly. I mean, and it's not just beginners. I always say you need an incredibly complex amount of tooling to make the simplest web application work today. And that's fine, but nobody understands the tooling. Not beginners, not mids, and most seniors do not understand how that tooling works. They do not understand what bundling is or how it works and loaders, etc. Even we're moving from our own framework, server-side rendering framework to Remix today, and we're pulling hairs out because Emotion needs a Babel plugin to run, and Remix doesn't allow Babel plugins, and we need to figure out a way to deal with that. Although, I mean, if I wasn't cognizant of how tooling works, I would just, throw Remix away. The tools work, but you need to do a lot of massaging and a lot of dealing with issues that are barely comprehensible to even the best senior. So I don't want that. I want a React app or an Angular app or whatever app. You just write the code, you point the web server to the root directory of that code, and you run it and press F5 or Command R if you're on a Mac. And it works. That's what I want.
Yeah, which is basically going back to the original vision of deploying apps to the web, right? Like when we made the switch from static web, which was HTML pages that everyone could write, people wanted to preserve this ability to just write code, which is supposed to be simple, and just deploy it, like have it ready, working.
And it's still there, that ability. I want to move the current modern development back towards that model. Absolutely. I mean, I understand why it moved away from that model. It had good reasons. We didn't have like a good language. We had ES5, ECMAScript 5, which was a really primitive language. So we needed to transpile from ES6, like ES 2015, to ES5. And no ESM, no ES modules native in the browser, so we needed to bundle. I mean, I understand the whole thing. I get it. But we now have the capability of going back towards a simpler model. And hopefully 2, 3, 4, 5 years ago and forward, we'll get there.
So yeah, that brings me to my next question. So how much time do you think will it take for, assuming everyone in the committee, those people are happy with the proposal, until we see type annotated JavaScript in the browser? Years.
Not because the browsers are slow. The browsers are very, very, very fast at implementing TC39 features. Really, if you're using a greenfield browser, and today all browsers are greenfield. Chrome, Firefox, and Safari, they're all greenfield. You're always working at the latest -1, latest -2 versions. All of them support all the features of JavaScript. There's no need to transpile JavaScript. TypeScript, different story, but JavaScript, there's no need anymore. So that's not the problem. The problem is that this is, well, two things. This is a huge, big change in JavaScript. There will be a lot of politics in the good sense, a lot of reading the spec and arguing over the details. And the details are very, very important in the spec. You can't just gloss over them. So you need to discuss the alternatives, etc. And when it's such a huge feature, it takes time. And the second thing is, we're all volunteers. We were doing it. This is all in our spare time. So yeah, it just takes time. So years. How many?
You're not doing this proposal on ground force time.
No. Yeah.
Wow.
On the sofa in the evening.
And I guess you say it's a big change, but also because JavaScript must be backwards compatible, you can't introduce something you will regret later into the language.
Exactly. Once it's in, you're done.
Because I know there was a similar proposal for Python that got accepted pretty fast. Like not super fast, but like in a year or two, I think they already got it in.
Yeah. I think the process in Python is faster. Don't get me wrong. I don't know. I've never done statistics, but it seems. I think a lot of it may be, but because there was again, it's all conjecture. There was Guido, which was a benevolent dictator for life, BDFL, so he could move things at a faster pace. I'm not sure the committee is a 60-person committee, which is very, very difficult to go through. But yeah, and we looked at that proposal, and it was in some ways a motivation and not a motivation. We looked at it and thought, yeah, we should do something similar, because that's what they did. Yeah, they went one place further in that now we completely ignore the types.
Right.
Today, they don't completely ignore the types. All the type information, the runtime ignores it, but it's available to the code. The metadata will be available to the code. We don't do that. Currently, we're just throwing away the type information.
Yeah, and it made a lot of sense to me, because you don't want to introduce too many changes to the language.
Yes.
On the other hand, once that's get in, you would not, there's an option that you wouldn't be able to change that in the future, right? Any decision you make kind of affects the future as well.
Yes. And there's a good criticism of the proposal. They're saying, once we put that types as comments, we cannot standardize the type system anymore for JavaScript. That's it. We're done. It's right. Like forever and ever. Well, my point is, okay, what do I care? I'm not a huge, I love types, but I think they should be a compilation thing and not a runtime thing. And people say, no, but C# in Java. And I say, wait. C# in Java, 99.9% of the types in C#, Java, Haskell, whatever, it's a compilation thing. It's not a runtime thing. You don't get a lot of runtime exceptions because of bad types. All of it happens during compilation. So that's one. And two, one day, if we really, really want a type system, and I don't think it will be possible, but if we want a type system or real type systems to standardize on, then we'll find a way. Love always finds a way. Nature always finds a way. Type systems will find a way to get standardized if we want it.
And that's an interesting question, because eventually tech is moving forward rapidly all the time. And we had the web for 35 years, right, as a prominent technology. Today, I see things about VR and what's not, and it's, for me, it's like, I'm not sure if even how the web would be a part of our lives in even 5 years. So how do you commit to a project for 5 years? It's fascinating for me. How do you see the future for...
Okay. 5 years isn't a lot. Not a lot changes in 5 years. I know. Really, not a lot. That's one. So, but and 10, 15 years is like, okay, fine. We don't know what's going to happen in 10 years. Two, VR has solutions. We have web VR, and in the future we'll have more stuff. I'm a huge believer in the web. It's proven itself time and time again to survive and proliferate in the face of enormous competition. I mean, think of Android and iOS. That's enormous competition from apps, from native apps. And still the web is there, and it's huge. And even lots of those apps are written as like very thin clients around HTML, around web. Like, I just downloaded a carb manager, if I'm doing keto, and it's obvious that it's a thin wrapper around the web app. And then I go to their site, and it's exactly the same. So I know that it's the same. Progressive web apps will solve 90% of the apps, and the other 10% will still be native, and that's fine. But I think that in the next 5 years, most of the apps we write in mobile will be web and not native and not Flutter. But that's digressing. Look at the desktop. Look what happened in the desktop. There's nobody uses native APIs to write a desktop app. Slack, Spotify. I'm not sure about Spotify. Spotify, WhatsApp. I think they're all what's it called? Around Chrome, the thing. Electron apps or whatever framework they're using. It's just a web app running in and why is that? First of all, it's a system that evolved, and I like systems that evolve. They have a problem in that they're ugly around lots of places. Like you can see that it's an evolution and not designed, like nicely designed. But just like anything that evolves, it tends to be able to survive things that were nicely designed don't do. I like things that evolve even if they're around the edges. The second thing, it's really, really easy for beginners to learn, which brings us back to the first point. Just write some HTML, write some JavaScript. My 14-year-old daughter, now she's 15, did that and had an enormous amount of fun just writing HTML, some JavaScript, and pressing F5 to see the results. And once it's great for beginners, they tend to go up the chain and become senior, slowly become senior. And then suddenly you have this huge mass of supposed beginners writing tons of GitHub code and packages and open source and whatever. And it's very, very difficult to fight against that. Okay. Because everybody knows the web, take even the most, everybody. But so those two things, very easy for beginners. So the mass of developers that know it is huge. And the fact that it evolved and it was not designed very nicely, I think those two will give a very, very bright future to the web. It will evolve with VR. It will evolve with AR. That's my belief in the web.
I buy into this future.
So yeah, invest in JavaScript, HTML, and CSS.
And may I ask, how is it like working with the committee? I'll just give a bit of context about so TC39 is basically composed of different people. Those that can actually vote need to pay a seat. They usually come from bigger companies that are involved with the web. So there's Google, Microsoft, etc. And I'm just curious, how was it to propose them the first draft of the proposal and in general, the communication with them?
Well, I did not do the proposition myself. Look, I'm just Gil Tayar. The people that are co-authors with me are not higher status because there is no status, but they know their way around it and their voice is much often heard. We're talking about people like Daniel Ossenwasser, which is the product manager of TypeScript, and Rob Palmer, which is the chairman of TC39. So I listened in and tore my hair out whenever somebody objected to something, but all I could do was listen in and not just say, wait, I have something to say. But Rob and Romula, who works with him, and Daniel were the three, I think, presenters, and they did a really, really good job. In the end, it was 2 sessions, I think total of an hour and a half, 2 hours of discussion around this because it was very big. And finally it went to stage 1, so we're very happy. But the process before that, there was a long process before that of writing the initial draft and then, making it better and rewording stuff and all that we worked. We have something like a discourse group and we work there on that. But it's mostly, silence, and the flurry of activity, and then months go, then another flurry of activity, and and that's it. But it's nice. The initial proposal, I wrote it, the first draft. So it was in Gil Tayar / types as comments. That was the GitHub URL. It was initially called types as comments. Now it's called type annotations. And Rob wanted to add more. It was private because we didn't want to tell everybody we're doing it until it could be made public. And Daniel was asking me all the time, can you add this guy? Can you add this woman? Can you add this with this person, that person, so that he can work with them and explain and try and convince them that it's a good idea, etc. And at one time he said, can you add, I don't remember the name, the inventor of C# and TypeScript and Turbo Pascal, Andre Hesselberg or whatever. And he's a personal hero of mine. He was like, when I got my first PC, that was like 85, 84, and I wanted something more than basic. Then Turbo Pascal came out, Turbo Pascal 1.0. It was the first IDE. It compiled very, very quickly, and I learned Pascal through it. And you can see his like Turbo Pascal, and then Delphi, if somebody remembers that, and then C#, and now TypeScript. He has his footprint everywhere in anything connected with languages and IDEs and whatnot. And then adding him to my repository was like, oh my God, I'm so happy. So yeah, I'm working with like people, very big people, but as equals, definitely as equals, but they do the presenting and everything.
How did they even came to hear about that private repository that you wrote? Like,
oh, okay. Well, first of all, how did I find myself in this position?
Right.
I wrote. I hate transpilation, right?
Yes.
And but I decided to, a little bit before Round Forest, I decided that my experience at Apple Tools showed me that we need types. It's the bigger a system gets, the more you need the types. It was getting hairy and problematic, but I didn't want TypeScript. Okay, so what do? So I researched something called JSDoc typings. It's TypeScript having the ability to read your comments and having the information in the comments. So you write a comment and you say @param, and you give the name of the param and you give the type, and it's a TypeScript type. So you can specify for each function exactly what its signature is, and for each class exactly what its signature is, and you specify everything, but it's all in comments. Right. So no transpilation. So I was researching it and I loved it, and today at Round Forest we're using that, by the way, JSDocs, for the backend. And I decided I want to write like a blog post about JSDoc and how it's great, and here's how you use it. So I wrote JSDoc typings, all the power of JavaScript without the hassle. I don't remember exactly the title. And the beginning was this rant about transpilation and how I didn't like it and how TypeScript, I always hated TypeScript, and then I blah, 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 blah. And Daniel Ehrenberg, who's called Little Dan in the social circles, read my blog post. And he said, hey, nice work. This is great. And gave me a few typos and things and I fixed them, obviously. He wrote to me at Twitter. We know a little bit from conferences, not too much. And then he said, what do you say? I have this idea where we define type syntax spaces as comments, blah, 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 blah. What do you say we, write a proposal for TC39? And I was like, oh my God, really? I want that. And he says, okay, fine. And then, like, during the weekend, I wrote the whole proposal. Like, wow. Boom. Yeah. And then we went to Daniel, back and forth, fixing, changing, modifying, refactoring, etc. And then he started bringing in other people, Rob Palmer as the first, and then they started talking to Microsoft because we understood that without Microsoft's backing, it's not trivial. to do something like for Microsoft as the creator of TypeScript. So yeah, and then there was this process of bringing in Microsoft and continuing to work on the proposal until it reached proposing, and we got it. So the whole thing was due to a blog post and the fact that Daniel saw it and liked it, and I talked about the whole transpilation thing. Yeah, lucky guy. Yeah.
So I'll would like to take a pause for a moment and just mention that this podcast, the conversation we're having, is sponsored very gracefully by the company I'm working in called FlyCode, which I don't know if you heard about it, Gil, yet. I sent you a couple of messages. But,
yeah.
FlyCode is helping product teams to iterate on their products, their web apps, by eliminating the need for a developer to make very small changes, like changing a text. So I guess now that you're a big shot architect, you don't get these tickets, but back in the day, you must have received those tickets of, I don't like the wording in this and that page.
Yep.
And I think every developer is like, wait, it's just in the HTML or the JSX, whatever technology you're using. Why can't someone just figure out how to change the text themselves? But, they don't have access for GitHub, usually, the people, like the product manager that wants to make the change, and they don't really want to get into the code, where FlyCode gets in and basically lets people that don't have coding skills to make changes to copy in web apps and to make those changes get into the code via pull request.
That's a great idea.
Thanks. So yeah, that's just that was a pause for. All right, so back into our conversation. So with the help of Little Dan and the other gang in Microsoft, you were able to put this proposal out now, and it was shown to the committee. What's next? What's going to be now?
We need to start working on making it ready for stage 2. So specing out the details, and in so we need to work on that. We're not yet ready. We're taking time off, etc. But that's the next stage. Stage 2 is where we come with an almost complete spec, detailing the tiny details. Obviously, the committee can say, okay, we want to change this, we want to change that, but that's the rough idea.
Wait, and what is this spec basically? Like, what does it contain?
It's a specific ECMA. If you look at the ECMAScript standard, it's first of all huge, and 2, it describes in minute details exactly how JavaScript is parsed, how JavaScript is executed, all the functions exactly how they are. There's like little algorithms for each and everything, so that the implementers, the Google Chrome and Apple WebKit and all those, can go through the instructions to see. Now, if we're changing the parsing of JavaScript, then we need to change those little places in the spec that say you need to do this, you need to do that. That is the work that we need to do. Change the spec and see. That's tough work. I have no idea. I look at the ECMAScript spec, and it's like Chinese to me. But we'll get the hang of it. And I have like people that are really in the know about this thing. So I'm sure we can do it.
Well, that's amazing. So we're kind of getting into the end of our show, and I just wanted to ask you, how do you suggest people to take interest in their tooling? So you said earlier in our conversation that even senior engineers don't know how their tools are working, and I think it's like for me and you that we work on tools for many years. It's very obvious. But how would you suggest people to start taking interest in the tools that they are using and the language, the other like primitives?
That's a good question. I don't really know, but I think it's important. Okay, one way to approach it, and that's the way I approach it a lot of times, is when something breaks, like your tooling stops to work, you update the dependencies, we all know that, and then, the build stops working or whatever. We've all been there. And my answer to that is, if you really want to understand, then don't try to fix the problem. And what do I mean by that? I know how people fix the problem. I call it the combinatorial method. They try this and this and this, and when that doesn't work, they try this and that and this. And when that doesn't work, they try that and that 2 and that 3. And when that doesn't work, they try that 3, that 2, and that 4. And then they try lots of combinations until something finally, boom, it works. And they continue on. They fix the problem, absolutely, but they still don't know what the problem was. And that's where I don't fit in. Okay, my solution is, you update the dependencies, your build stops working. Why? To answer the why, you have to understand how the tooling works, and that's tough. You have to have in your mind a mental model of what is the data flow, what is happening to your code during the process of transpilation and bundling. Or if you're using Remix or Next, how does Remix work? How does it interact with your code? I just did that to a colleague of mine, a mid, and we went in painstaking details how Remix runs, the app server, and then the request gets, and then Remix comes in, and then our code goes in, and then Remix comes in, and the whole thing, we outlined exactly how Remix works. First of all, it helped me understand how Remix works, because when you're explaining something, you're understanding it. And second, it helped her have a mental model of how things work, so that when something breaks, she will know how to look for the problem, because she understands where the problem is. So having a mental model of how the tooling works is the first step in understanding what the problem is. And that's tough, because the information isn't out there very much. It's all in GitHub issues and whatnot. And some tools have a very good place where this is how it works. But most tooling most tool documentation is do this, do that, do this, do that.
Right, and not more like the concept of how
exactly. And I'm like, no, please just tell me how it works, and I'll figure out the details. So you have to figure it out. Ask people, write in groups in Facebook or in whatever, Stack Overflow or whatever. Try and understand what the problem is. And then once you understand what the problem is, the fix is usually very simple. And it's probably much simpler than the combinatorial fix you tried back when you tried to fix the problem and not understand.
So basically,
my take on it, and it's not just tooling; it's on everything in programming, is don't try and fix the problems. Try and understand what the problem is, what its root cause is. Get a mental model of how things work, and then everything will be fine.
I think that's an amazing advice for any engineer tuning into our show. Gil, this was tremendous. Love speaking with you, as always. And any action that you would like to ask the audience for? Some shout out?
No, I'm good.
All right. Well, it was splendid to have you here. And everyone will have other amazing talks in the future. So please subscribe, and we'll see you next time.
Bye, everybody.